Good morning, everyone. Thank you so much for joining the Redington virtual event session. Today's topic we have from Microfocus Fortify Securing Application Source Code, and the session will be delivered by our lead consultant, Mohammad Sirajuddin. In case you have any questions during the session, I would request you to please put in your questions in the Q&A tab, and Siraj will be able to answer all of the questions towards the end of the session. Siraj, over to you.
Thank you, Bindia. Thank you very much. Team, good morning. This is Mohammad Sirajuddin, and I'm the lead consultant at Redington Gulf. I manage the Microfocus security. So as part of today's session, we will be discussing on static application security testing, which is SAST, and we'll discuss on Fortify's SCA, the source code application, and to see how we can secure the source code. So in today's session, we'll understand a bit about what is the current methodology, what is the current trend, the issues, some basic understanding of the normal process that is being executed within the organization, where we understand what exactly is the life cycle development happening. And we'll also have a look into the product, which is Fortify SCA, Source Code Analyzer. And then we'll have a small demo to understand, to just get a look and feel of how SCA looks like. So proceeding further, if you look into specific vulnerability, if you look into reports from be it a Gartner report, be it from Homeland Security, be it Mandiant report, be it a WASP report, multiple other reports, everyone suggests that over amongst the entire landscape of attacks and threat that happens, the biggest number of attacks happen on the application. Application are the most vulnerable component of an organization that gets attacked huge amount of time. So if we look into an organization, the organization at many times, we see that they may be running a legacy software. Some of the software will be in-house developed, where they have their own developers working on that. They may have outsourced the development activity to a third-party company, or they may have procured commercial software, maybe Microsoft, SAP, Oracle, be it anything, or they may be running open source, some open source software. They may be using it, but in all aspects, what is expected from the IT security or from the IT team is that they ensure that security is up and running, the security is managed, and we are achieving the compliance. There is no data breach, there is no violations. We ensure the compliance is met. We always ensure that the applications are protected and monitored. This becomes actually a big challenge, because the customer's environment can be of varied component, as has been described here. Now, what would be the best approach to ensure that we have we have software assurance in place? How do we ensure that the software that we are using, we have assurance of that software security assurance? So how do we ensure that we have software security assurance achieved in our organization, despite we have so much of varied environment? So the very first, it is software security assurance can be achieved in 3 different steps, which we will discuss now. The very first step is securing the development. In case if the organization is having applications being developed by using their own developers, or by having it outsourced to a third-party company, in both the scenarios, we need to ensure that the source code is developed in a secure way, meaning that there are no vulnerabilities within the source code. In the second phase, where we have the applications developed by us or by outsourced company, and the commercial applications, the open source applications, all these 3 applications, all these 3 categories together, when we are deploying them, when we have deployed in our environment into this particularly at the pre-staging area or in the pre-production area, staging area or the pre-production area, we have to test the applications again. Once we are testing it at the source code level, now in the second phase, for applications which we do not have the source code and for application which we have the source code available, for both of these applications, we have to do a second layer of testing where we take 360-degree view into consideration. Like we take into consideration the application source code, we take into consideration many other aspects. The operating system, the network components, the communication between the application and the database, everything gets into picture at the second layer. Once during the second phase, we get to see the application is neat and clean, we allow we as the security team allow the application team to deploy the application into the production, which is go live. So once the application is go live, the third phase gets into picture, which is protecting the application continuously and monitoring it. Now, we are very well aware that the custom applications that we build are not strong enough in terms of logging. Say, the max that we can expect from a custom application is error handling. They might write some source code, some logs to indicating about some error codes, but we cannot definitely expect them that they will develop applications in a way where we get security logging. Now, these security logs are most important for our security team members. They may be utilized by the SIM solution and provide visibility to about the application. So now the challenge on the third level is that we need to have appropriate source code. We need to have appropriate process in place where we generate the logging. So and once the logging is generated, we also need to have a mechanism where we protect the application. Probably if there is an SQL injection attack or if there is a cross-site scripting attack happening, there has to be an interface which blocks this attack. So if we have these three phases in place, like starting from the development till the production, if we have these phases in place, then we can assure that then we can be rest assured that we have software security assurance in place. We have tried our best to ensure that the entire software running in our organization is secured. If we look into the landscape of last 10 years, we see that 10 years ago when the applications were released, there were very few updates being released to it. And as and when the threatscape was in, time has been passing, the threatscape also increased. Now, for every application that we have, there are many more updates released very frequently when compared 10 years ago. Why? Because this is because of the sophistication of attacks. If we look into some of the reports, probably the Gartner, one of the report from Gartner, it was indicating that the development team should work very closely with DevOps, with the security team to ensure that this code that is developed is actually having security embedded in itself. This has been a recommendation coming directly from the Gartner. But in today's environment, if we talk about DevOps, this is very far adopted by organizations because DevOps gives you the rapid development of applications. You go and if we go and ask a developer who's a part of DevOps team that how are you taking into consideration security, the default or the de facto answer we get to hear is DevOps process ensures that security is already embedded. But how many of them go for a security testing? Not more than 20%. I would say actually less than 20% of the developers or the companies go ahead with the security testing after the software is developed. Least privilege and least importance is given. We are going at a rate of 80 developers to one security team member. We have to increase this number, we have to increase the frequency, we have to gel up, there should be a gel up between the development and the security team together. So let's understand how Fortify is going to help us achieve this software security assurance. You remember in the previous slide we discussed there are three phases where we achieve the software security assurance. So the similar way here, we have Fortify supports in achieving the software security assurance in three phases. One is the static analysis phase, another is the dynamic analysis phase, and the third one is the runtime analysis phase. This phase is for applications which are in development stage, or for which there is continuous updates or any other updates happening where developers are working. For this is for applications which are either already in production or which is about to be released, and this is for the applications which are already in production. So let's see how Fortify achieves this, supports this methodology. So when we have developers developing the source code, Fortify provides source code analyzer as a product. When the developers, this source code analyzer, once we test the source code in using the source, once we test the source code using the static code analyzer, and if the results are good, there are no vulnerabilities found, it is moved on to the second stage where we are into the staging area, where we have application into the development staging or the pre-prod area. Here we have a product called Web Inspect. The Web Inspect analyzes the product, tests performs the security testing. We call this as the dynamic testing, exploits the vulnerabilities. In this phase, we exploit the vulnerabilities existing within the application, and then we come out with the report. So once we get a neat and clean report at Web Inspect, we allow the team to proceed with the production and deployment. Once the application is in production deployment, we have a third module called App Defender, which is runtime application protection. So this third module is going to protect the applications in real time. If there is an attack happening from an attacker onto the application, like if he's sending a malicious code, the App Defender becomes a barrier and it protects that code from reaching out to the application. That is the protection module. If it also as a monitoring module, any calls that is reaching out to the application, it is monitored through security and the logs are shared to the SIM solution so that the security team gets visibility of what is happening, who is calling, which specific file is the application being called for, what is the health of the application. So you get many more information, many more insight information about this application. The security team starts to monitor the application. On top of all these three applications, we have Software Security Center, SSC. We call this as SSC, and we call this as SCA, Source Code Analyzer, Software Security Center. So all these three products are integrated with Software Security Center. And this is like the management portfolio, which gives the management clear visibility of what is happening, what vulnerabilities exist in what application, how much of that is fixed, how much of that is unfixed. This also provides you a workflow methodology on how to manage and create the workflow. Now, in today's demo, we have, after this presentation, we have a small demo. Probably we have SCA and Software Security Center. We'll try to do a small demo on both of these. Just to understand how things move on. So this entire scenario is based on premise, which means the customer will be installing it on their premises. So the source code, be the source code available, it will be within their premises. Be the application, it is going to be within the application. The testing is done within the premise. And at certain instances, the customer might say, man, I do not want on premise, I do not want to install anything. If you have a service, please do also offer me. So on demand, Fortify on demand is a SaaS based service where you can buy the credits, the subscription units, and utilize it for any kind of scan, any kind of these three scans. Coming on to Gartner, if this is the 2019 Gartner report. If you look, you see Micro Focus here. If you Micro Focus Fortify listed here into the Gartner Leaders Quadrant. And this is probably the ninth time in the sequence that Fortify is into the leaders quadrant. So to be rest assured that you are working with one of the vendor, one of the leaders of the vendor. So what does the customer, what does Fortify, but how does the Fortify benefit the customer? It provides ROI at an extremely very faster pace by fixing the vulnerabilities or by fixing the issues at the very early stage, as early as the development stage. And it also supports the application to detect any vulnerabilities at the pre-production area before it is getting into production. So because of this, the time that is saved is extremely high. So Fortify helps the customer in saving the time, saving the resources, saving by protecting them in terms of breaches, application breaches. Let's proceed further. In today's session, we will be discussing about static application security testing, which is the SAST, which is all about how do we protect the source code. So what is SAST? SAST is static application security testing, meaning that we are protecting the source code by scanning the source code line by line, identifying what is the meaning, what is the framework adopted, what is the methodology used, understand everything, and then identify vulnerabilities within them. This helps in identifying vulnerabilities at a very earlier stage so the developers can fix them immediately and ensure that the source code, whatever has been developed, is free from vulnerabilities. The SAST also provides IDE, integrated plugins. So IDE plugins are a component which gets integrated with the developer's work environment, like the Visual Studio. If the developer is developing Android application, it can be integrated with IntelliJ. If the developer is developing an application based on .NET or Eclipse, the Java, then we can use Visual Studio or Eclipse. We can integrate IDE plugins with them. So with this, the developers, before they commit the source code, they can scan and they can benefit out of this. Let's have a small understanding of how a workflow will be organized within an organization by keeping this in mind. At the step one, we have the developers using their laptops or their workstations where they are developing the source code. They may be using anything. They may be using .NET, Visual Studio. They may be using Java, Eclipse. They may be using Android or IntelliJ. We have plugins for them. The developer scans the source code. Now, the developer, before they usually commit, usually what happens, the developer writes the source code and then commits to the repository. But now the developer will write the code, it will scan the code using the IDE plugins, thereby making one layer of protection here. So IDE plugin is going to identify the vulnerabilities. The developers are fixing the vulnerabilities before they commit the code to the repository. So now as a result, the quality of the code that is committed after IDEs is completely different when compared to without IDEs. Now we have already the source code repository receives a source code which is already has gone through one layer of quality check. Now this source code, through the process of continuous integration or direct integration, the source code is shared with the SAST tool, the Fortify Source Code Analyzer. In this server, we have installed the Fortify SCA. So the Fortify SCA is going to scan the source code files which is shared, and then the report is published. The auditors review the results that is shared by the Fortify SCA. They analyzes the report. Any false positives are highlighted, and only the ones which are exploitable are the developers review the result, and then what vulnerabilities are there, they open a bug in the bug tracking tool. saying that this is a vulnerability. So the bug tracking tool will in turn share this information with the developers. So the developers gets to see, okay, there has been a bug which is filed by the auditors. Now let's work and get this fixed. So this chain repeats itself until we get a neat source code. The auditors see a neat source code without vulnerability source code scanned. So once we see no vulnerabilities, we proceed with the next layer, which is the web inspect layer, which is the dynamic scanning. So what the software, what does the SAST help us? SAST help us in fixing, finding more vulnerabilities, fixing them at a very early stage, thereby helping us in reducing the time and the cost involved. This is a small integration of Fortify SCA with different tools. They are very well-known tools which developers use in a day-to-day life. If the team is using bug tracking tools like Jira, Bugzilla, ALM Octane, we support them. We'll be integrating with them. If they are using work environments like Eclipse, Visual Studio, then we integrate with them. If they are using TeamCity, Visual Studio TFS, we support them. Jenkins as a continuous build server, we support. Sonatype as an open source, we support it. We have a huge list of support that we provide. And this is a small idea of a small snippet about the level of programming languages that we support. We support more than 25 programming languages. And I would say this covers more than 90% of the languages that is being developed in any organization. So we have something called Fortify Security Assistant. And so some time ago, in a couple of slides earlier, we discussed on IDE plugins. Here we are discussing about Fortify Security Assistant. Security Assistant is a process or a phenomenon, is again a kind of plugin that is added to the developer work environment. So the developer here is using an Eclipse environment, and you can see Fortify existing here. This is Fortify Security Assistant. So what does it do is Security Assistant, as and when the developer is writing the code, it immediately identifies vulnerabilities and it gives an idea. Like when the developer clicks on this, he gets to see what vulnerability is this. It gives a detailed explanation of this, and it gives further information like what different vulnerabilities exist, what is the sequence, all the details, and it also gives the chart like which application, what page you are, where did we find this. So Software Security Center. So Fortify SCA integrates with Fortify SSC, Software Security Center. So this Fortify Software Security Center is managed by, probably is accessed by multiple team members. The development team members, where the development lead to the developers have access to it. The security team member, like the application team members, like the auditor has access to this. The security team members have access to this. The management, the CISO has access to this. Multiple team members have access to this application. So what does this application provide? This application provide detailed information about the results of the applications that has been scanned. Like it gives information about what application, what vulnerabilities, what exactly is the line of code, what vulnerability is that. It lists out all the vulnerabilities. It gives detailed information about the vulnerability, what exactly is the vulnerability. And this is how the dashboard would look like. When a CISO logs into the application, he will see the list of applications and the amount of vulnerabilities existing in that. So within a quick span, he will understand the state of his applications and the vulnerabilities associated with them. If the development lead logs in and he looks into this particular dashboard, he understands in a moment that if he fixes these three categories of vulnerabilities, he is fixing 80% of the vulnerabilities in the entire organization, the application vulnerabilities. 80% is covered up. So Fortify helps the customers, helps us understand what is priority, what needs to be picked up first. So in addition to that, so Fortify helps us in identifying false positives, true positives. When we talk about audit results, there can be many things associated in that. There can be false positives as well. Not that we do not have false positives. We do get false positives as well. There will be definitely true positives. There will be results which are not exploitable, but still identified because they might not be as per the best practice. They might not be in a way it has to be written. Everything is highlighted, and Fortify classifies them based on the criticality, based on their severity, like critical, high, medium, low, not an issue. This is how it is being classified, and for each of them there is a answer provided. There is a notes provided which gives you detailed information about the vulnerability. Now, how does SSC, Fortify SSC, help us in fixing the vulnerable false positives? So we have something called Fortify Audit Assistant. So this is a artificial intelligence based machine learning technology. So how does it work is the developer or the security lead, sorry, it's not the developer, it's the security lead who logs into the SSC, and then they get connected to the third party tool, which is from Fortify. It's not third party, it's from Fortify, but it's hosted onto the cloud. They get connected to the audit assistant, and they upload the results to the audit assistant. So the audit assistant uses the AI based technology, whitelists, identifies what is probable false positive and what is most likely the vulnerabilities. And the most likely vulnerabilities identified by audit assistant is more than 90% are sure to have vulnerabilities. So here, this is how we ensure that we identify the false positives. This is a automated mechanism to identify false positives, but the traditional mechanism, which is deployed by a vast majority of the customers, is by utilizing their own developers as auditors. They have a different team of auditors, or they utilize their existing developers to work as auditors and then fix it. So that is far more utilized tradition than using audit assistant. But yeah, as a process, we do have something available to help our customers to proceed in fixing, to identifying false positives and fixing them at much faster rate. When we talk about Fortify on Demand, Fortify on Demand is the cloud-based solution, as I said. So here you do not need to provide any infrastructure or any deployment. You do not need to have any deployment experience. You do not need to know how to integrate or how to use it. Everything, it's just simple. You get a tenant access based on the data center location chosen or the nearest data center for your location. And once you log into the tenant, you will see what subscription units you have. You can utilize the subscription units and select the scan, what scan you want to proceed with. And then once you finish the scan, you get the report. And if you're selecting a scan plus environment, you also get a technical account manager. You also get a technical account manager who will support you in understanding the results and just providing you a helping hand in assessing the results. These are the 4 major data centers that we have across the world, and you will be receiving the tenant from one of these data centers. We have one in APAC, one in EMEA, another and two in Americas. Now I think it's time to go with the demo. Let's have a small look into how the web inspect, how Fortify looks like. Seems like Vindhya is messaging me. Sure, Vindhya. Sure, I'll be doing it. Yeah. So we have Fortify Audit Workbench here, and I'm just opening the results in Audit Workbench. This is how the Audit Workbench looks like, and the Audit Workbench has multiple. Once we have logged into the Audit Workbench, we have this is how the result looks like. We see the number of files that are scanned. We actually see the build ID. We see the scan date. What is she saying? We have the results available. We have This is how the results are published. We have it tells like how many lines of code are there, what are the lines of code existing, and what are the vulnerability issues. The very first thing that we select here is the filter set. You have multiple filter sets that you can select. I'll prefer to use the security auditor view. Once I select the security auditor view, I get to see the vulnerabilities highlighted based on the severity. So now you see here, these are the labels. Like first label is the critical label, and then I have the high label, then I have the medium label, and I have the low label. I have some best practices as well. So based on the severity, the issues are identified. So what did I scan? I just published the result of a scanned application. So I just published a result of the scanned application, and the scan. I didn't scan the application right now because the scanning will take another 15-20 minutes. I didn't want to keep you on wait. So I scanned the application before we started the session, and then not before, like in the last session, and I just utilized the same results just to take you through the console. How does it look like? So as you see in the application that we have processed, the SCA has processed, there are 265 vulnerabilities here. There are 265 vulnerabilities. And of these 265 vulnerabilities, um, we have categories. We have divided these 265 vulnerabilities. We can define them on any of the aspect. Like I can select OWASP based on PCI, I can define them, or based on SANS, I can define them. Based on OWASP, I can define them. So what the by default categorization is through the category. For example, I go ahead and I select on basis of OWASP. Like for example, OWASP top 10. If I select OWASP top 10, the categories get changed. It's A1, A3. So OWASP, like it has a list of A1 to A10. So now the application that we scanned has A1 to A7, A1, A3, A4, A5, A7. So these are the categories. But let's understand from category point of view, this categorization is based on the type of vulnerability. So based on the type of vulnerability, we have different vulnerabilities executing here. So if I go ahead with command injection, okay, now it says that 0/3 means 3 vulnerabilities exist of type command injection, of which 0 is fixed. So 0 is fixed, yani it has not been reviewed anything. So once we review, we can do the analysis here. So there is a process to it, how we go through here. The very first line here you see is exec.java colon. So which means this is before the colon, whatever you see is the file name. After the colon, what you see here is the line number, which means exec.java is the file name and 103 is the line number within that. The moment I click on this, it opens exec.java file and it highlights line 103 in this. So here it gives us the method. It details about why is it being considered, why is this line 103 being considered a vulnerability. Command injection, it gives a brief abstract of what exactly is this. It's really a brief, like like couple of lines. The methodology, like the formula that has been used here with calls execution with command built from untrusted data. Okay, so which means that something is being executed coming from an untrusted data. This call can cause program to execute malicious code. Yeah, if untrusted data is coming in, untrusted data can come from any source, probably the user. He might be sending some data. It might be trusted or untrusted. So yeah, this can be a vulnerability. But how did I just saw one line 103. How do I get to know from where the data is coming in? It's not telling me. It is just highlighting me a line 103 where I'm executing something. But where is the sequence where the data is coming from? That information is provided by analysis trace. Analysis trace tells you here you are at line 103. I'll just go up. We are at line 103, but it tells me the entire sequence from where the get parameter is there, from where the value is being fetched, how the value is being assigned, and how the value is returned, and how the value is moving on until it comes to the execution parameter. So with this information gives a huge amount, this adds a huge amount of value to the developers. Developers will see the value immediately with this. And here it tells you detailed information. In the abstract process, we just saw one line information, two line information. Here you see the same information, but in a detailed way. It gives you explanations and examples defined. What are the examples? With examples like this is how you are executing it, different examples. And here are the recommendations. It gives you recommendation how you can fix this. The developer, once he goes through this recommendation, he gets immediately an idea that, okay, how do I fix it up? So this is how Fortify helps the team in fixing in identifying the vulnerabilities. Now let's go to the Fortify SSC. This is my Software Security Center. I'll just refresh it. Now let me log in as say I have a user account created as manager. Okay, I'm a manager who's logging in. Okay, so I logged in as a manager. Now think of it in this way, that I'm the manager, security manager, and I got to hear that my development team has completed developing or writing the source code for one single application. This is the very first time they are doing it. Now, what I'm going to do is I'm going to first send them a questionnaire, where I'm going to ask them a list of questions. Based on the answers that they provide, I'll create an application. So this is my application first thing that I'm going to do. The application name is WebGoat. People who are of the application security team, they understand what WebGoat is. WebGoat is a very well-known application built with purposeful built vulnerabilities. So if I have already an existing application, I'll click on add to existing application. So this is a new application that I'm adding. So I'll fill the details here. So this is not an existing application version. So I'm writing the version as 1. So I'll go ahead next. And here I have to select, I'm modeling an application. I'm first creating an application within SSC. So I'm selecting, yeah, it's an active development. This has web access, APIs. This is access through API. This is actually internally developed. My developers developed this. It has ASP.NET and it has Java. And accessibility external to public can access this. HTTP basic authentication, HTTP, that's enough. This is an application. So now I'm explaining my team. I'm explaining SSC that what exactly is this. So this is a high risk application for me. I'm selecting a high risk template. I'll proceed. Now, who should have access to this? So as a team, as a project manager, I have some user accounts already created. So I'll say project manager is the user called manager, and security manager is also the user called manager. Development manager is I have developer, and team is admin, analyst, developer, and manager. So I'm selecting who should have access to this application. Probably I have developer. I may have developer 1, 2, 3, 4, 5. I may have multiple sequences. So based on the sequences, I have just one application. Probably application 2, I will not give access to developer 1. I'll give access to developer 2 only. So I have the option of selecting which team member to allocate the access. So now I just created the application. I assigned whom should have access to this. So now I have one application already created. Now you see one application created already. Now let's go back to our Fortify SSC. Okay. I'll close the project. I can sign in. So I'll sign in as a, say for example, developer. So say I'm an analyst. But let me do it from admin to be more quick and process oriented. Say I'm an analyst or the auditor. I'm the auditor who did the review of source code analyzer. So I got the results. I scanned the application, and this is my application that I scan. I click on the application. Now it's opening the application. So as an auditor, I did the analysis, and I now have to upload this data to the SSC. So I click on upload audit project. So since I as admin had access to, as a user, had access to one application called WebGoat will automatically be seen here. I logged in. Before I opened the project, I did a normal login to the application. So since I logged in, SCA has now been connected to SSC. So as per the user I logged into SCA, I got to see the application access. So now I know there is only one version here. I select the version, and now it's doing a permission check whether I have privilege to upload the results. We do have a role called view only role, which means that I can only view. So if I have a view only role, and then if I try to upload a scan result, I'll get an error. So it does a first privilege check, and then based on that, it allows the access. I click OK. It gave me a message that the audit project was already uploaded. Now, let me go back to my scenario. I'll just log out from this. Okay, now I'll try to log in here. This time, let me log in as manager on this, and I'm logging in. So now, as an auditor, I had uploaded the results. After uploading the results, I sent an email to the security team that the results are uploaded to have a look. So now I'll go ahead and have a look. I'll go to the applications. Sorry. I'll go to audit. In the artifacts, now it tells that WebGoat 101, someone has uploaded by, say for example, I had logged in as admin. Suppose it was an analyst. As analyst, I had logged in. I see my analyst user ID. Admin had uploaded a result. So now, should we go ahead and approve to display this? I say I'm the manager. I know, yeah, I understood like the development team has an application called WebGoat because I created the application. I say, yeah, it's approved. Go publish the result. And then I approve it. I give my comments, whatever the comments are there, and I approve it. So as a manager, I approved it. So here I get to see the result. What happened is whether it is processing. So it was like a 5 MB file, a 2.5 or 2.5 MB file. So it will process. It might take some time. I'm not sure how much time does it gonna take because I've built this application on my laptop. Wow, my laptop is good. So I see processing is complete. Now let me go to the dashboard and see what happened. The moment I come to my log into my dashboard, I get to see that I have one application, WebGoat, and I see like there are 1,279 vulnerabilities within that. And I have open issues is 1,279, issues pending review is 1,279, meaning that nothing is resolved. Whatever the open issues pending is also the same thing. We have not fixed anything. So let me go to this application and see what exactly is happening. The moment I go to the application here, it tells me like, man, with 265, you have 265 critical vulnerabilities, 99 high vulnerabilities. I click on critical vulnerabilities. Okay, I click on critical. So now here I only see the critical vulnerabilities listed. So now I get to see, okay, what is this vulnerabilities? What exactly are these? Say, for example, I saw something called privacy violation. I click on the privacy violation, and what does the privacy violation talks about? Super S. Now it gives me it gives me information about what exactly is this, whether this is what exactly is this. What I can do is I can have a comment added to this. I can have a comment, like for example, I can assign this particular vulnerability to a specific user. I can say, okay, let this specific user called developer work on this. So now I just assigned. So I'm gonna save it. As a manager, I reviewed. I might be the security manager, or I might be the security manager, which I do not have idea of what the coding is. I might ask the development lead to log in and do this job of assigning vulnerabilities to whomsoever the team members is. So now what happens is I got one particular vulnerability, which is privacy violation, assigned to a specific user. So similarly, vulnerabilities can be assigned to any kind of team members. We have bug tracking, we have integration with bug tracking tools. We can have this integrated with bug tracking tools as well. Or if I find this as a vulnerable, not a vulnerability, I can suppress the issue. I can give the audit. I can mention it as whether not an issue or what exactly the practice, and I can mention this as not a vulnerability. Okay, and I have, so this is how the results are published. This is how the results are assigned to the users. Now the user, whoever it has been assigned to, once he logs in, he can see that he has specific applications assigned to him. Like once he goes there and clicks on my assigned issues, for me it says 0 issues. But if I log in as a developer and I click on my assigned issues, I will see the issue that was very recently assigned to me. So that is how I can go ahead and fix the vulnerability, fix the make the workflow assigned. Now coming to the reporting segment, how do I create some reports? I can generate multiple reports here. I can give a report name like OWASP, give some title name, browse the version, like I know I have WebGoat. I want to generate a apply report for WebGoat. I select WebGoat, select next. So OWASP PCI, so there are too many things already included. Now let me remove these things. I'll keep it simple. I'll keep it only OWASP. Just to show you a sample. So I'm just generating this. I'll select this as the PDF. I'll select generate. So once the application it is processing, as I told you, it's done on my laptop. It might take some time for the report to be generated. So once it is generated, you can download the report. And by the way, in the administration tab, you have okay, it's generated. Let me just read the file now. Application summary, web code, this is the application name. I have the details of the application, what vulnerabilities exist, how do they look like, um, you know, as per web inspect, as per OWASP calculation, how many of them are there? As per the vector classification, what is the classification? And it is showing one. This is the one because I just assigned only one vulnerability or only one user. So scan engines. This is about the scan engines. How many scan engines have added to this? This is about the application details, and here my application vulnerability starts. So this is basically the application results, what percentage and how it is. So as per their categorization, how critical are how many. We have 38 critical vulnerabilities. So this is generic application, how it comes. So this is one simple report that I have generated. There is a huge list of reports that you can generate. You see this, there's a huge list of reports that you can generate based on different mechanisms. There is a big list that you can generate. So this is how Fortify helps you in, this is just, I've done the integration with SSC, the SSC with SCA. You can do integration with Web Inspect, you can do integration with App Defender and multiple things together. So this is how Fortify provides you a mechanism to ensure that you are managing the security. I would conclude with this. And thank you very much for your time. Let me just have a look into if there are any questions existing. Okay, I believe I've finished the session as of now. Bindya, are you there? Okay, gentlemen, thank you very much. Thanks for joining in the session. I'll conclude this session with this. Thank you very much. You can log into the Redington Value channel into the YouTube, and these trainings will be posted onto the Redington Value. The previous trainings have also been posted. You can go there and have a look into the YouTube videos whenever you need. Thank you very much. In case if you have any questions, you saw my email address, you can reach out to me any point of time. Thank you very much. Bye-bye.